Hello, great friends. My name is IBM and I welcome you to my YouTube channel. I'm solving Cambridge AS Physics 9702. This is May June 2023 papers and I'm solving paper 1-3. So without wasting time, I would like to take you to the question paper and we try to solve it. These are solved past paper questions. This is paper 1, multiple choice questions. So here we are. This is 970213 May June. The paper is 1 hour and 15 minutes and I'm going to try to keep time. So without wasting time, the instructions, this is paper 1 multiple choice. I will not waste time on that. We are used to the instructions, so I'll go straight to question number 1. What must be included in a record of a physical quantity? Of course, a physical quantity must have a unit, whether you are assigned or not assigned, but should have a unit and should have a magnitude, whether it is a scalar quantity or vector quantity, should have a magnitude. So let's see, it should have an integer value for the quantity. An integer could be positive or negative. It should have an SI unit. It may not have an SI unit, but could be having a unit. So this is not a must. It should have a numerical value for the quantity. This is the magnitude. A unit expressed in base units. It may not always be expressed in base units, so the answer is C. As long as it is having a magnitude, it can be a physical quantity. What will be missing is a unit. So a physical quantity must always have a magnitude. That is a must. What is the ohm expressed in SI base units? Remember, the ohm is the unit for resistance. So I have resistance is equal to V over I. V is in volts. I is in amperes. And remember, V is energy per unit charge, where energy is force times distance, that is kilogram, meters squared per second squared divided by charge. Charge is IT, which is ampere seconds. So it means the units for resistance will be for V, which will be kilogram, meters squared. S minus 2 divided by S becomes S minus 3. 1 over A becomes A power minus 1. I'll reduce this thickness. Okay, so then divide by I, which is A. So when I divide, this is kilogram meters squared S minus 3, A minus 1 divided by A, it becomes A minus 2. So the answer is automatically going to be A. Kilogram meters squared S minus 3, A minus 2. The desk has a true width of 50 centimeters. True width. Two students X and Y measure the width of the desk. Student X uses a tape measure and records the width of 49.5 plus or minus 0.5 centimeters. Student Y measures uses a meter ruler and records a width of 51.4 plus or minus 0.1 centimeters. So you notice that 0.49 is closer, 50 compared to 51. But then when you look at the precision, this is plus or minus 0.5. This is plus or minus 0.1. So this is more accurate but less precise. This is more precise. This is less accurate but more precise. Accurate but not precise. Less precise. Less accurate, more precise. Which statement about the measurement of student X is correct? It is less accurate. That is not true. X is more accurate compared to Y. It is more accurate and more precise. When we compare the uncertainties, it means Y is the one which is more precise. So the answer is going to be D. X is more accurate but less precise than the measurement of student Y because the instrument here has a smaller uncertainty, plus or minus 0.1, so it is more precise. The diagram shows two vectors, X and Y, drawn to scale. These vectors are drawn to scale. If X equals to Y minus Z, which diagram represents the vector Z? x is y minus z. Okay, I'll just try to manipulate this. X is y minus z. So I keep y in the same direction and I reverse z. Okay, x is y minus z. So x equals to y minus z, which also means x plus z should be y. If I get x and I add z, I should be able to get y. Okay, so if on x I add y, if on x I add z, I should be able to get y, and y is in the horizontal. So if I keep y in the horizontal, this is y is going to be the resultant. So it means I have to draw z the other way around like this. If on x I add z, I get y. If I add x to z, I get y in the opposite direction. Alternatively, I can say z is equal to y minus x. That means on y, I add x but reversed. Y is horizontal. Instead of drawing x going upwards, I reverse it. So x will be, because it is y minus x, so this is y. Then I reverse x, will point in this direction. So this is clockwise. It means z is going to be here, which is going to be anti-clockwise. So this means the answer is automatically going to be A in all cases. Z is A. Which equation representing uniformly accelerated motion in a straight line can be determined using only the definition of acceleration? If you remember the definition of acceleration is the rate of change of velocity. So this is final velocity minus initial velocity divided by t. So v is equal to u plus at. So the answer is going to be C. An object moves from rest with a uniform velocity horizontal and uniform acceleration vertically. Which graph shows the variation with time of the displacement of the object from its initial position is correct? So these are graphs of against displacement against time. So we know that the gradient is the velocity. Gradient is equal to the velocity. Horizontal displacement, for horizontal, if we consider horizontal displacement with the time, the gradient, the velocity is constant. Velocity in the horizontal remains constant. V in the horizontal is going to be constant because acceleration in the horizontal is 0. So that means A is wrong and B is wrong because A shows a decrease in the gradient. This one shows that the velocity in the horizontal is decreasing to 0. And this one shows, this one also shows that the velocity, that is vertical. This one shows that the velocity in the horizontal is increasing, yet velocity remains constant. It should be a straight line if the velocity remain constant in the horizontal. Then let's look at the vertical. For the vertical motion, velocity in the vertical, as the body goes upwards, an object moves from rest with uniform and uniform acceleration. Which graph shows the variation with time of the displacement of the object from its initial position is correct? So they said it has uniform acceleration vertically. So that means V in the vertical should increase. And how do we show an increase in velocity in the vertical? The gradient should increase. This one is wrong because it shows velocity is decreasing since the gradient is decreasing. This one is correct because this one shows that the velocity in the vertical is increasing because the gradient of this curve is increasing. So the answer is D. A device for spraying paint consists of a box with its four faces, horizontal and vertical. One of its vertical faces contains small holes. Paint is fed into the box under pressure via a vertical tube and exits through the holes as fine streams moving horizontally. The paint is ejected at a speed of 2.5 meters per second. I'll call this one V. Through 400 holes, each of area 0.4 millimeters squared. So changing this area, it becomes times 10 power minus 6 to change it to meters squared. The density of the paint is 900 kilograms per meters cubed. What is the horizontal force required to hold the device stationary as it ejects the paint? Horizontal force. Of course, we know that force is the rate of change of momentum. So force is going to be equal to the rate of change of momentum. Remember, there are the force on each hole is going to be the rate of change of momentum for that particular hole. But then there are 400 holes, so I'll multiply this by 400. So force is going to be 400 times, okay, we know that momentum is mass times velocity. The change in momentum is going to be equal to mass times the change in velocity. So the force is going to be 400 times the mass, then times the change in velocity or change in momentum, which is mass times change in velocity divided by t. I want you to also remember that mass is equal to density times volume. This was small v for velocity. This is capital V. So it means the force is going to be equal to 400 times mass, which is density, times the volume. Remember, the volume is cross-sectional area times another length. So this will be times the mass. Mass is density times volume, where volume is going to be cross-sectional area times another length, then times change in velocity. If we assume one of the velocity is 0 and the other one is v, so the change in velocity is small v. Then this is going to be divided by time t. I want you to know that L over T is also V. So it means the force is going to be 400 times density times area. L over T is V, then times V. So I'll get the force, the horizontal force, from 400 times density times area times V squared. So this is 400 times the density, which is 900 times the cross-sectional area, which is 0.4, by 10 power minus 6 times the speed squared, which is 2.5 squared. So I'll check my calculator. Where is the calculator? So let me find the calculator. Okay, so my calculator, 400 times 900 times 0.4 exponent minus 6 times 2.5 squared. So this is 0.9. So the force is 0.9 newtons. So the answer here is going to be B. Each diagram illustrates a pair of forces of equal magnitude. Equal magnitude. Which diagram gives an example of a pair of forces that is described by Newton's third law? According to Newton's third law, the two forces must be of the same kind. Same kind, acting on two different bodies, on two bodies. One acts on the other body, another one acts on the other body. These two are acting on the same body, so this is not Newton's third law. These two are also acting on the same body, so this is not Newton's third law. These two are acting on the same body, this is not Newton's third law. So the answer is going to be B, because the gravitational pull of the moon acts on the earth and the gravitational pull of the earth acts on the moon. These two forces are of the same kind. They will be equal but opposite, so the answer is B. Two balls of identical shape and size but different masses are falling through the same liquid. So that means they are falling in the same density. The sum of the drag force and upthrust acting on each ball is equal to the weight. In other words, weight is equal to the drag force, the upthrust, plus the drag force, which is the viscous drag V. Which statement about the two balls is correct? Let me just sketch this. The first one of mass, let it be mass M1. Its weight is W1. Let the upthrust here be U1 and the drag be V1. Then for the second one, its mass is M2. The weight is W2. The upthrust is U2. They say they have different masses. They are falling through the same liquid. The sum of the drag force and the upthrust acting on each ball is equal to its weight. So when I sum up the upthrust and the drag, I get the weight for both. Which statement about the two balls is correct? So notice that they don't have the same mass. Let's say M2 is greater than M1, which means the weight W2 is greater than the weight W1, which means if I get this is upthrust 2 V2, it means that U2 plus V2 is greater than U1 plus V1. So which statement about the two balls is correct? The heavier ball has a larger acceleration than the lighter ball. The heavier ball, both because the forces are equal but opposite, in both the acceleration is zero, so that one is fine. The heavier ball has a smaller deceleration. In both the acceleration is zero because the forces, there is no resultant force. The resultant force for both is zero, so this one is wrong, this is wrong. The heavier ball is falling at the same speed as the lighter ball. They are falling at a constant speed, but the speed may not be the same. That is not true. The heavier ball is falling at a larger speed than the lighter ball. So this is going to be true because now the terminal velocity of the heavier ball is going to be higher than the terminal velocity of the lighter ball. Because if they are moving at a constant speed each, these constant speeds are not going to be the same because the weight W2 is not the same as the weight W1, since the masses are not the same. So it means the heavier ball has a larger terminal velocity than the lighter ball. So the answer is going to be D. A perfectly elastic collision occurs between two objects, x and y. The mass of x is m and the mass of y is 4m. Objects x and travels at speed v before the collision and speed 3v over 5 in the opposite direction after the collision. What is the kinetic energy of y after the collision? Okay, so I will find the kinetic energy of x before the collision because this was at rest. Total kinetic energy here is a half m v squared. And I'm going to use conservation of momentum. If I conserve momentum, total momentum before it is m times v because this was at rest. So total momentum is m times v plus 0 equals to total momentum after velocities to the right positive, velocities to the left negative. So this is going to be after the collision, let the velocity of this one be vy. So this is going to be 4m times vy, that's its momentum after the collision, plus negative, so it becomes minus m times 3v over 5. So m has cancelled out. M has cancelled out. I'm making vy the subject, or I can just multiply this by 5. So I have 5v equals to 20vy minus 3v. So I'm making 3vy the subject. So vy is going to be equal to 5 plus 3, that is 8v divided by 20. So that is vy, the velocity of y after the collision. So I want to find what is the kinetic energy of y after the collision. So kinetic energy is a half mv squared. So it is going to be E. Kinetic energy of y after the collision is going to be a half times the mass, which is 4m, times the velocity, which is 8v divided by 20, but this is squared. So this is going to be 4m divided by 2 times 64v squared divided by 400. So when we simplify this by 2 1 by 2 2 by 4 100, so this is going to be 16 divided by 50 because this is 100 by 4, this is 16. Then by 2, this is 1. By 2, this is 50. So this is 16 over 50 m times v squared. So 16 over 50 mv squared. What is not a requirement for two forces to act as a couple? Remember, for two forces to act as a couple, they should be equal, they should be parallel, they should be in opposite directions. Their lines of action should never meet. Lines never meet. So the two forces act in opposite directions, that is a requirement. The two forces act through the same point. That means their lines of action are meeting. So this is not correct. So the answer is B. The two forces combined produce a zero resultant force. That's true because they are equal but opposite. The two forces have equal magnitude. That is true. So B is not a requirement. A uniform meter rule is pivoted at 34.0 centimeter mark as shown. Note that it is a uniform meter rule, meaning its weight acts at the midpoint. The rule balances when a 64-gram mass is hung on the 4 centimeter mark. What is the mass of the meter rule? So since it's a uniform meter rule, its mass will be at the midpoint. So let's call this M. So the mass is going to cause a clockwise moment when this one is causing an anti-clockwise moment. So for equilibrium, the two moments are going to be equal. So I'll say M times the perpendicular distance. This is 50 minus 34. 50 minus 34, I think this is 16. And then this is 34 minus 4, which I think this is 30. So M times 16 is going to be equal to 64 times 30. So M is going to be 64 times 30 divided by 16, which is 120 grams. So this is 120 grams. It is grams because I didn't change it to forces. So the answer is C. A volume of 1.5 meters cubed of water is mixed with 0.5 meters cubed of alcohol. The density of water is 1000 kilograms per meters cubed and the density of alcohol is 800 kilograms per meters cubed. The volume of the mixture is 2 meters cubed. What is the density of the mixture? So density is mass over volume. The density of the mixture is going to be total mass divided by total volume. Remember, mass is density times volume. So the density of the mixture is going to be total mass. For water, it is mass density times volume. That is 1000 times 1.5 plus the mass of alcohol, density times volume, which is 800 times 0.5 divided by total volume is given as 2.0. So I'll just press my calculator. 1000 times 1.5 plus 800 times 0.5. So this is 1900 divided by 2, which is 950. So the answer is going to be D. An object is falling at a constant speed through a viscous liquid. Fu is the upthrust on the object due to the liquid. Wl is the weight of the liquid displaced by the object. W naught is the weight of the object. Which equation must be correct? Now it is moving at a constant speed, so the resultant force is 0. So the weight is given as the weight of Wl is the weight of the liquid. This is the weight of the object. W naught is the weight of the object. Then the upthrust is Fu. It is moving at a constant speed. So if it is moving at a constant speed, then the resultant force F is W naught minus the upthrust force. But since V is equal to a constant, then it means acceleration is 0, resultant force is 0, which means W naught should be equal to F due to the upthrust. So W naught is equal to the force due to the upthrust. So the answer here is going to be equal to, which equation must be correct? WL is the weight of the liquid displaced. W naught is the weight of the object. The object is falling at a constant speed through a viscous liquid. WL is the weight of the liquid displaced. So of course, according to Archimedes' principle, the force due to upthrust is equal to the weight of the liquid displaced. The upthrust force is equal to the weight of the liquid displaced. So I think the answer is going to be A. The answer is going to be A. W naught is the weight of the object. No. Because an object is falling at a constant speed through a viscous drag. So this is the weight is acting downwards. But what is making this to move at a constant speed? WL is the weight of the liquid displaced. Of course, according to Archimedes' principle, the upthrust force is equal to the weight of the liquid displaced. This statement is correct. Then let's see. Fu is W naught minus WL. This one is not correct. F upthrust is equal to the weight of the object. The upthrust is upwards. No, this one will not be correct. The upthrust force is not equal to the weight of, we are not sure if it is equal to the weight of the object unless if the upthrust is equal to the weight of the object, then if the upthrust is equal to the weight of the object, then the object would not be moving completely. It would have stayed on the surface of the liquid. So this must be the weight of the liquid displaced. So this is not correct. This one is also not correct. So the answer is going to be this one. I'm saying if the upthrust was equal to the weight of the liquid initially, then the object would not be moving even. But since the upthrust is equal to the weight of the liquid displaced according to Archimedes' principle, so it means with the time the weight of the liquid displaced would balance with is balancing with the upthrust. So now it means the object would be moving with a constant speed. So the answer is going to be A. An airport has a mechanical system for moving luggage. The system uses a horizontal conveyor belt, a sloping conveyor belt, a lift, and a frictionless slide. A suitcase is moved around the airport. Of course, here we know that speed decreases, kinetic energy decreases. Here, speed remains constant. The change in kinetic energy here is going to be 0. Here, speed increases, kinetic energy increases here. But here, potential energy decreases. Then here, from to lift this upwards, potential energy increases to lift this for 10 meters because potential energy is equal to mg times h. Resistive forces opposing the motion of the suitcase are negligible, for which movement of the suitcase is the net work done on the suitcase greatest. So work done here, the potential energy is small along 16, potential energy is small, and the kinetic energy is constant. There is no change in the kinetic energy. So there is no more work done here. So along 16 meters, I will ignore this. Moving the suitcase a distance of 16 meters at a constant speed along the horizontal conveyor, there is less work done there. Moving the suitcase a distance of 80 meters at a constant speed, no change in kinetic energy, but there is a gain in potential energy due to this height. But this height is smaller than 10 meters, so it means the energy here is the work done here is smaller than the work done at 10 meters, so we also ignore A. Then moving the suitcase distance of 10 meters at a constant speed. So here kinetic energy, change in kinetic energy is 0, but there is potential energy due to this height because it is mgh. This is a greater potential energy. For all cases, the kinetic energy was remaining constant. But here, there is more work done because of a greater height, h. So the answer is going to be C. Moving the suitcase a distance of 12 meters at increasing speed downwards on the slide. So here, as the speed increases, there is gain in kinetic energy, but there is loss in potential energy. So the work done is going to be the loss in kinetic energy plus the gain in kinetic energy. So that means the work done here is going to be smaller. for 12 for the suitcase moving downwards. So the answer is C. A car moves along a horizontal road with a constant velocity v against a resistive force F. The engine of the car has an efficiency of 25%. What is the input power to the engine? So we know that power is equal to force times velocity. Let's first find the output power. So this will be the output power. And then we know that efficiency is equal to is 25 over 100. But efficiency is output power, which is F times V divided by input power, which I'm calling power in. So if I make power in the subject is going to be FV times 100 divided by 4, which becomes 4 FV. So the answer is C. An object of mass 0.4 kilograms is projected into the air and follows a curved path above horizontal ground. The object takes time 1.5 seconds to move along its path. The object lands a horizontal distance of 18 meters from its initial position. Air resistance is negligible. What is the kinetic energy of the object at its maximum height? So first of all, at maximum height, velocity in the vertical goes to 0, but velocity in the horizontal remains there. Vx will be the same as initial velocity in the horizontal. So all we need is to find the initial velocity in the horizontal. So considering horizontal motion, and I use S is equal to ut plus a half at squared. Remember, in the horizontal, acceleration is 0 for if air resistance is negligible. So this part here becomes 0. So displacement in the horizontal is 18 equals to initial velocity in the horizontal, which is ux. The time taken is 1.5. So ux is going to be equal to 18 divided by 1.5. I think 18 by 1.5 is 12. So 18, this is 12 meters per second. That is the initial velocity in the horizontal. Remember, velocity in the horizontal remains constant because there is no acceleration in the horizontal. So even at the highest point, velocity is 12 meters per second. So it means kinetic energy is going to be a half times mass times velocity squared, which is going to be a half times the mass. What is the mass is 0.4 times the velocity, which is 12 squared. So we have a half, which is 0.5 times 0.4 times 12 squared. So this gives me 28.8, which is approximately 29. So the answer is D. A metal wire has length 5 meters, 5.2 meters, and diameter 1.0 meters. The metal has Young modulus 360 gigapascals. The wire is fixed at one end and the force is applied to the other end. The force extends the wire by 7.2. So this is the extension. This is original length. This is diameter. This is Young modulus. The wire base hooks towards the force applied to the wire. So by definition, Young modulus is equal to stress over strain, which is force over area divided by strain. Strain is extension over original length. Stress is force over area and strain is extension over original length. So this will be times original length over extension. And I want you to remember that cross-sectional area is going to be pi d squared divided by 4. So it means the Young modulus E is going to be force times L naught, the 4 goes up, divided by pi d squared times E. So I make F the subject. F is going to be pi d squared E times E, divided by 4 L naught. So this is going to be 360 for Young modulus times pi times D, 1 times 10 power minus 3, but this is squared, times E, 7.2 times 10 power minus 3 for the extension, divided by 4 times L, which is 5.2. So this is 360 times pi times 7.2 exponent minus 3 times 1 exponent minus 3 but squared divided by 4 times 5.2. So I'm getting 3.9 times 10 power minus 7. Let me press the calculator again. 360 times pi times 7.2 exponent minus 3 times 1 exponent minus 3, but this is squared, divide by 4 times 5.2. Oh, Young modulus was gigapascals. So this one is times 10 power 9 times 10 power 9. I'll just multiply the answer by 10 power 9. Did I press it correctly? Three 360 exponent 9, 360 exponent 9 times pi times 1 exponent minus 3, but this is squared, then times 7.2 exponent minus 3 divided by 4 times 5.2. Okay, so I think that is correct. 391, which is approximately 3.9 times 10 power 2. So there is a times 10 power 9 here for Young modulus because it's gigapascals. So the answer is going to be B. The graph shows how the length of the spring varies with the force applied to it. The spring has an stretch length L0. When a force F is applied, the spring has length L1. What is the work done? Of course, work done is going to be equal to the area under the graph. So this is going to be a half times F. Then this is L1 minus L2. I mean minus L0. This one is F. This is L1 minus L0, but this is a triangle, so it is a half base times height. So the answer is going to be B. A progressive wave of frequency 1.5 kHz travels in a medium at a speed of 340. What is the minimum distance between 2 points? I'll call that distance x on the wave that have a phase difference of 70 degrees. Remember, phase is equal to 360 into the distance between two corresponding points compared to the wavelength. And we notice that the wavelength is equal to V divided by frequency, which is going to be 340 divided by 1500. That is wavelength. So phi is 70, so I'll say 70 divided by 360 is equal to x divided by wavelength, which is 340 divided by 1500. So I make x the subject. I'll just simply say 70 divided by 360, then times 340 divided by 1500. So x is 0.44 in meters. So x is 0.044 meters, which is the same as 4.4 in centimeters. So the answer is going to be A. Graph 1 shows the variation with the time of the displacement along a progressive wave. Graph 2 represents the same wave and shows the variation with distance of displacement at an instant in time. So graph 1 is displacement against time. This one gives us the period. So the period is 0.4 seconds. This is the period. Graph 2 is displacement against distance. So this one gives us the wavelength. And the wavelength is 120 centimeters. What is the speed? So V is equal to lambda times F, which is lambda times, because F is 1 over T, so this is lambda over T. So it means V is going to be the wavelength 120 centimeters divided by the period, which is 0.4 seconds. So 120 divided by 0.4, that is 300 centimeters per second. So the answer there is D. A vehicle moves with a constant velocity along a road directed towards an observer. The observed frequency of the sound from the vehicle changes as the vehicle moves past the observer. Which phenomenon explains the change in frequency? The observed frequency changes, that is called the Doppler effect. Apparent change in frequency due to relative motion between the source and the observer. So that is the Doppler effect. An electromagnetic wave has wavelength 2.1 centimeters in a vacuum. Which region of the electromagnetic spectrum contains this wavelength? So we know that Rumenera's mother is visiting Uncle Xavier's garden. Visible light is around 10 power minus 7. This is 7 times 10 power minus 7 to 4 times 10 power minus 7. This is red. This is violet. So on this side, I will go on adding. I will just add plus 3. So this is going to be micro, 10 power, around 10 power minus 5. That is my infrared. Around when I add plus 3, this is going to be around 10 power minus 2. This is micro. 10 power minus 1, that is infrared. I mean radio waves. Radio waves is 1 times 10 power minus plus 4. 10 power minus 1. This is radio waves. So the next region is micro. So this is times 10 power minus 2 in meters. So this must be microwaves. So the answer here is going to be B, microwaves. It can't be infrared because infrared is 10 power minus 5. Radio waves maximum is 10 power minus 1. Visible light is 10 power minus 7. This is minimum is 10 power minus 1. This is around 10 power minus 5. So 10 power minus 2 is automatically infrared, microwaves. A source of plain polarized light is observed through two polarizing filters. The filters are positioned so that the source appears at its brightest. Okay, that is maximum intensity as before. One of the filters is then rotated clockwise and the other is rotated anti-clockwise through the same angle. How does the source appear when both filters have been rotated 90 degrees and 180 degrees from their initial positions? So we know that I is equal to I naught cos squared theta. If both have been rotated through 90 degrees, the transmitted intensity is going to be I naught cos squared of 90, which is equal to 0. So if both go through 0, we shall just see darkness. So darkness, so it is not brightness. Then if it is 180 degrees, they have been rotated through 180 degrees, then it means the theta is going to be 0. So alternatively, we can check cos of 180, which is negative 1, and squared, it is 1. So I is going to be equal to I naught cos squared of 180, and this will be equal to I naught. So the transmitted intensity is the same as the incident intensity. So darkest and brightest. So the answer is going to be C. The diagram shows a string stretched between fixed points x and y. There is a stationary wave on the string. The solid curve shows the string at a position of maximum displacement at time t equals. So the dashed curve shows the other position of maximum displacement. A straight central dashed line shows the mean position of the string. Points S on the string is directly above point P. Point T on the string is directly below point Q. Which statement is correct? Of course, let's look at P. P will always be at maximum displacement, just like Q will also be. This is an antinode, and this is an antinode. R is a node, so this one will always be permanently at rest. R will always be permanently at rest. So which statement is correct? A short time T naught, at a short time after T naught, point R on the string will be displaced. Point R is permanently at rest because it's a node. A short time after T naught, point S, I said this one is a node, so a node is permanently at rest. A short time after T naught, point S and T on the string move in opposite directions. Of course, S has reached maximum displacement, so it is now going to be vibrating downwards after a short time T. After a short time, then T has reached maximum displacement, is going to be now vibrating in the opposite direction. So the question is, this is a short time after T naught, point S and T are on the string moving opposite directions. That is very true. Particles this side are vibrating downwards. They will be vibrating downwards. Particles this side will be vibrating upwards. This is downwards. No, that is not true. The vibration is the other way around. These particles after S, they vibrate in opposite directions until we have a crest, a trough here, and these ones will be vibrating now in the opposite direction. So that is going to be correct. The distance between P and Q is 1 wavelength. That is not true. Distance between two antinodes is half wavelength. So this is not true. Two moving points on the string that are equal distance from point R vibrate in phase. Any equal distance from R will be in different segments, and we said these are always in antiphase. Particles in two different segments are 180 degrees out of phase. So particles here vibrate 180 degrees out of phase with particles in this segment. So that is not true. The answer is going to be B. The variation with the distance x of the intensity I along a stationary sound wave is shown. If this is a stationary wave where the intensity goes to 0, this must be a node. This must also be a node. And we know that the distance between one node and the next node is always half wavelength. So it means the wavelength of this wave is going to be twice this distance here, 5 and 15. This distance is going to be 10 centimeters. So it is going to be 2 times 10 times 10 power minus 2 in meters. What is the frequency of the sound wave? So frequency is going to be V over wavelength, which is 340 divided by 2 times 10 power minus 2. So we press the calculator. 340 divided by 20 exponent minus 2, which is 1700 hertz. So the answer here is going to be A. An experiment is set up to demonstrate the diffraction of water in a ripple tank. The waves pass through a gap of width W, and some diffraction of the waves is observed. The wavelength is now doubled. What is the new gap width needed to cause the same amount of diffraction? So I want you to note that diffraction is maximum. Diffraction is maximum when the wavelength is approximately the same as the width of the gap. Because the wavelength has been doubled, the width of the gap should also be doubled for diffraction to be maximum. So since the width was initially W and the wavelength has been doubled, then the new width should be twice W. So the answer here is going to be C. That is to produce the same amount of diffraction. Two coherent electromagnetic waves are traveling in a vacuum. The two waves meet at a point. They are coherent, meaning they maintain a constant phase difference. At this point, the two waves have different intensities. Which statement about the waves is not correct? I want you to remember intensity is directly proportional to amplitude squared. So two coherent electromagnetic waves are traveling in a vacuum. The two waves meet at a point. At this point, the two waves have different intensities. If they have different intensities, it means they have different amplitudes because intensity is directly proportional to amplitude squared. The two waves have different intensities, so they should be having different amplitudes. Which statement about the waves is not correct? They have a constant phase difference. That is true because they are coherent. They have the same amplitude. This is not true because amplitude is directly proportional to intensity. Intensity is directly proportional to amplitude squared. Since they have different intensities, they have different amplitudes. Of course, they should have the same frequency, they have the same speed. But this one is not correct. For waves to be coherent, for the word phase to be used on waves, they should have the same frequency. A polar beam of light of wavelength 600 nanometers is incident normal on a diffraction grating. The distance between adjacent slits, so this is wavelength, the distance between adjacent slits, so this is going to be D for the grating, is 12 times 10 power minus 6. A screen is placed parallel to the grating at a distance of 1.5 meters from the grating, a third order. So this is small n is 3. The third order diffraction maxima are observed at the two ends of the screen. What is the distance between the two ends of the screen? So I will say this is x and this is x, so this is 2x. I want the distance between the two ends, that is x plus x. So I will just find x first. So if I find x, let me call this angle theta. Somebody should be able to see that tan of theta is equal to the opposite over the adjacent. This adjacent is 1.5. So x over 1.5, that is x. X is going to be 1.5 times tan theta. But then n lambda is equal to d sine theta, which means that sine theta is going to be equal to n, which is 3, wavelength, which is 600 nanometers, times 10 power minus 9, divided by d, which is 2 times 10 power minus 6. So what is theta? So I have 3 times 600 exponent minus 9 divided by 2 exponent minus 6. Then I have the sine inverse of the answer. So theta is 64 degrees. So theta is 64.2 degrees. So tan theta is equal to x. So x is equal to 1.5 tan of 64.2 degrees. So x is going to be 1.5 tan of the answer. X is going to be 3.1. So x is 3.1 meters. So the distance between the screen is going to be 2x. 2x is 3.1 times 2, which is going to be 6.2. So the answer is going to be D, 6.2 meters. A metal wire is connected between the terminals of a cell. Okay. So let this be the metal wire, and let this be the terminals of the cell, so that there is a current in the wire. Which statement is correct? So if this is a positive terminal, we know that current flows from positive. So this is the wire. So current flows from positive to negative, and electrons flow from negative to positive. Negatively charged electrons in the wire move from the negative terminal to the positive terminal. That is correct. Negatively charged nuclei, the nuclei do not move. There are no negatively charged nuclei in a wire. Positively charged electrons, there are no positively charged electrons in a wire. Positively charged nuclei in the wire move from the positive terminal to the negative terminal. The positive A current in a wire is due to flow of charge carriers, which are the negative electrons. So the answer is going to be A. Electrons flow from a negative terminal to the positive as current flows from positive to negative. So the answer is A, according to Benjamin Franklin. Two resistors of resistance R and 2R are connected in parallel with a battery of EMF 12 volts and negligible internal resistance. The total power dissipated is 36. What is the value of R? So these resistors are in parallel. So total resistance is equal to the product, which is 2R times R, over the sum, which is 2R plus R. This gives me 2R squared divided by 3R, which is 2R divided by 3. That is total resistance. Total current is EMF over total resistance, which is going to be EMF is 12 over total resistance, which is 2R divided by 3. The 3 goes up, so it becomes 3 times 12 divided by 2R, which is 1, that is 18, divided by R, that is the current. So power is equal to I squared times the total resistance there. So 36 is equal to 18 over R, this is squared, times total resistance, which is 2R over 3. So this is going to simplify. I will say 36 equals to 18 times 18 times 2R divided by R squared times 3. So 1R cancels with that square. By 18, 1 by 18, this is 2. This 2 cancels with this one. I remain with the 1 on the left hand side. So I have 3 is equal to 18 over R, or 3R is equal to 18. There's one R in the denominator, so I have 3R equals to 18. So R is going to be 18 divided by 3, which makes this to be 6. So R is 6 ohms, so the answer is D. The wire has a resistance length of 3 meters and is made of metal of resistivity 4.9. Potential difference of 12 volts is applied across the wire so that it has a current of 1.4. What is the cross-sectional area of the wire? So we know that resistance is equal to rho L divided by cross-sectional area, but resistance is also PD over current. So cross-sectional area therefore is going to be, I'm making A the subject, is going to be rho L times I divided by V, which is going to be rho is 4.9 times 10 power minus 7, L is 3, I is 1.4 divided by V, which is 12. So from my calculator, it's 4.9 exponent minus 7 times 3 times 1.4 divided by 12. So this is 1.7 times 10 power minus 7 meters squared. So the answer is going to be B. A cell of negligible internal resistance is connected in series with a thermistor, a fixed resistor, and an ammeter. The thermistor is placed in a beaker of water and the temperature of the water is slowly increased. So temperature is increased, the resistance of the thermistor decreases. I will sketch something here for the circuit. There's an ammeter, there's a thermistor. So the temperature is increased for the thermistor, so the resistance of the thermistor decreases. A graph of current I against the temperature T of the thermistor is plotted. Which graph could show the variation of I with T? So the resistance of the thermistor decreases. So total resistance, so because this was fixed resistor, so total resistance R total decreases. Total resistance decreases, which means the current in the circuit increases. So where we see current decreasing, that is going to be wrong. As they said, the temperature of the water slowly increased, which means resistance of the thermistor decreases, which means total resistance decreases. And remember, the current is equal to the EMF over total resistance. Because total resistance decreases, the current increases. This is wrong because it is showing as temperature increases, current decreases. This is also wrong, as temperature increases, current decreases. This one is also wrong. Current is somehow constant and it decreases. It must increase, so the answer is B. As temperature increases for a thermistor, its resistance decreases because it's called a negative temperature coefficient thermistor. So its resistance decreases. And as resistance decreases, total current in the circuit increases. If the total current in the circuit increases, then we should look for a graph which has increasing current, and that is going to be B. A battery of with internal resistance is connected in parallel arrangement of two resistors and a switch S as shown. Initially S is open. Initially S is open. Let me call this one internal resistance small r. So it means the lost volts, initially the lost volts equals to I times R. Remember the EMF is equal to the terminal PD plus the lost volts. So now when the switch, what happens to the voltmeter? So it means V, that is the reading of the voltmeter, is E minus the lost volts. Okay. What happens to the voltmeter and the ammeter readings when switch S is closed? So the moment we close S, what happens to total resistance? Initial total resistance was R1 plus R. If this is R1, this is R2, this is R. Then after, total resistance is going to be R1, R2 over R1 plus R2, then plus small r. Let's use numbers. Let's just use numbers. Let this be 1, let this be 2, let this be 3. Initially, this would be 2 plus 1, which is 3 ohms. And this one would be 2 times 3 over 2 plus 3, then plus 1, which is 6 over 5 plus 1, which is 2.5. So you see, the total resistance decreases. Here it was 3, and here it has decreased. So total resistance has decreased. But the EMF has not changed. So it means the current is equal to EMF over total resistance. So since total resistance has decreased, it means the current through the circuit has increased. And if the current has increased, it means the lost volts, which equal to I times R, have increased. The lost volts have increased. Remember, V is equal to the EMF minus the lost volts. Since the lost volts have increased, it means this difference has become smaller, which means the potential difference, the reading of the voltmeter decreases. So the current increases, so we ignore this one. Ammeter reading increases. Then the voltmeter reading decreases, so the answer is A. Kirchhoff's first law states that the sum of currents entering a junction is equal to the sum of currents leaving the junction. I say this is conservation of charge. The second law, which is sum of EMFs, is equal to sum of PDs in a closed loop. That would be conservation of energy. So the answer there is automatically A. Two resistors have a combined resistance of 34 ohms when connected in series. Okay, so in series, it means when I get R1 plus R2, I should get 34. The same resistors have a combined resistance of 7.4 when connected in parallel. For resistors in parallel, if there are only two, the total resistance is the product over the sum. So in parallel, I have R1 times R2 over R1 plus R2 should give me 7.4. So what remains is just solve those two equations. I have two equations and two unknowns, so I should just solve them. This equation means R1, R2 is the same as, remember R1 plus R2 is 34, so this is going to be 7.4 times 34 when I make R1, R2 the subject. This means that, this is going to mean that R1 should be equal to, what is, R1 should be equal to 7.4 times 34 divided by R2. So this is 7.4 times 34 divided by, okay, so this is going to be 251.6 divided by R2. So I'm going to use inspection. I'm going to check inspection. Suppose if R2 is equal to 15, what is R1? So I will divide this by 15. R1 will be 16.8, and R1 plus R2 is equal to, so I have 16.8 plus 15. So this is not equal to 34. So it means this is out. I will check 17. If R2 equals to 17, R1 equals to, so I have 251.6 divided by 17. This is, R1 is going to be 14.8. So 14.8 plus 17, that is 31 point. So here also R1 plus R2 is not equal to 34. So I cross out this one. Let me check the next one. If R2 equals to 23, what is R1? So R1 will be 251.6 divided by 23, which is 10.9. So this is 10.9. So if I try to find R1 plus R2, this is 33.9, which is approximately 34. So it means the answer is going to be 23. So the answer is C. A potential circuit is used to investigate the EMF of a cell X. The EMF of cell X is known to be approximately 0.5. So this is 0.5. It is the same PD across PQ. So PD across QP is the same as the EMF of cell X, which is 0.5. Because this part here, PQ is in parallel with cell X for when there is balance. The driver cell has negligible internal resistance and an EMF of 2 volts. So it means the PD across QR is 2 volts. PD across QR should be equal to the driver cell, which is 2 volts. Okay, the sliding contact is moved along the uniform resistance wire between ends Q and R to a point P where the reading on the galvanometer is 0. That is if there is balance. What is an expression for the approximate length QP? Of course, if I compare the potential differences, they should be directly proportional to the lengths. That is, potential difference across QP divided by the potential difference across QR should be the same as the length QP divided by the length QR. They are directly proportional. So V across QP is 0.5. V across QR is 2 volts is equal to the length QP divided by the length QR. So it means QP is equal to 0.5 divided by 2. 0.5 divided by 2, that is 0.25, which is 1 over 4. So QP is going to be 1 over 4 times QR. 1 over 4 times QR, which makes the answer to be automatically A. Here comes particle physics. The table contains data for 4 different nuclei, P, Q, R, and S. Nucleus, number of neutrons, nuclear number. Which 2 nuclei are isotopes of the same element? So for the same element, isotopes should have the same proton number. So number of nucleon number minus neutron number, you get proton number. So this is 10 minus 5, proton number here is 5. 10 minus 6, proton number is 4. 14 minus 6, proton number is 8. 16 minus 8, proton number is 8. So these ones which have the same proton number are supposed to be the isotopes. So we have R and S. The answer is D. Which statement about beta minus decay is correct? Remember, for beta minus decay, we have a neutron inside the nucleus changing into a proton to give us beta minus, which is 0 minus 1. And this is normally accompanied, a normal particle, which is a normal electron, is accompanied by an antineutrino. So a neutron changes to a proton, which is true in the nucleus, and an electron and an antineutrino are emitted. So the answer is A. A neutron changes into a proton in the nucleus, that is true, and the electron neutrino, this is not true. A proton changes to a neutron, this is going to be beta plus, and an electron antineutrino, this part will not be correct. This will be beta plus, but beta plus is accompanied by a neutrino. So the answer to this question is A. And lastly, what is the quark composition of a hydrogen 3 nucleus? So this one has 1 proton plus 3 minus 1, which is 2 neutrons. So 1 proton is up, up, down, plus 2 into 2, there are 2 neutrons, each neutron is up, down, down. So you have 1, 2, up, 2 times 2, that is 2 times 1, that is 2. So you have 2 up plus 2 up, so you have 4 up. And then you have 1 down plus 2 times 1, 2, that is 4 down, which is 5 down. So you have 5 down and 4 up. 4 up, 5 down, 4 up, 5 down. The answer is going to be A. And that marks the end of the multiple choice questions of the papers done in May, June 2023. I hope you have learned something. If there's any mistake, something you don't understand, you can always leave a message. I'll always try my level best to answer your questions. Until next time, bye bye.